All right, everybody, let's talk about extension cords. Now, we don't think a lot about them, but they're actually the leading cause of residential fires. Not just because they're extension cords, it's the improper use of extension cords. Now, according to the Electrical Safety Foundation International, extension cords cause about 3,300 residential fires annually, resulting in 50 deaths and 270 injuries. Yes, they're convenient, but they're only designed for temporary use with low wattage devices. When you use them or misuse them with high power appliances or tools, you create a serious fire hazard. The cord's gonna overheat, the insulation's gonna melt, and before you know it, you have an electrical fire on your hands. Okay, so why does this happen? Well, extension cords are rated for a specific amperage and wattage. When you exceed these ratings, several things are gonna happen. Number one, heat generation. Electrical current flowing through a wire generates heat. The higher the current, the more heat. Extension cords, especially cheaper ones, have thinner wires than the permanent wiring in your walls. Then you have something called voltage drop. The longer the cord, the more resistance it creates. This means appliances don't get the full voltage they need, which can damage motors and electronics. And then you have insulation breakdown. When a cord is overheated repeatedly, the plastic insulation deteriorates or degrades. This eventually exposes the wire inside, and that creates a shock or fire hazard. So the rule of thumb is, if an appliance generates heat or has a motor, it probably draws too much power for an extension cord. All right, so what appliances are we talking about here? Number one, refrigerators and freezers. Never plug these into extension cords. Refrigerators draw 6 to 12 amps and cycle on and off constantly. This creates power surges. They need a dedicated outlet. Refrigerators typically run for decades, and an extension cord isn't designed for that kind of continuous long-term use. If your refrigerator can't reach an outlet, call an electrician to install a proper receptacle. It'll cost you a couple $100s, but it could save you thousands in spoiled food or fire damage. Microwaves. Microwaves draw between 600 and 1500 watts. That translates to 5 to 13 amps. Most extension cords are rated for only 13 amps maximum, leaving no safety margin. During that power surge, when your microwave kicks in, you could easily exceed the cord's capacity. I bet you didn't think coffee makers and toasters were a danger. Well, they are. Now, they may seem innocent, but they generate a tremendous amount of heat. A typical coffee maker draws 5 to 13 amps. Toasters can draw up to 15 amps. Both concentrate heat in a small area, and if that heat extends to a cord underneath or behind them, you've created a fire hazard. Now, if you're in a kitchen without enough outlets, just use a power strip with built-in overload protection for small devices only, not for heat-generating appliances. All right, the next category of appliances are heating and cooling appliances that you should not use an extension cord with. Space heaters. This is the number one culprit for extension cord fires. Space heaters can draw 1500 watts or 12.5 amps on high settings. They run for extended periods, generating continuous heat through the cord. You definitely want to plug a space heater into a wall outlet only. If your space heater can't reach an outlet, move the heater or move your furniture. Air conditioners. Window units and portable AC units draw massive amounts of power, typically 10 to 15 amps for smaller units and up to 20 amps for larger ones. Many require dedicated 220 volt circuits. Using an extension cord can cause the compressor motor to work harder, shortening the AC's lifespan while creating a fire risk. What about hair dryers and curling irons? Hair dryers draw 1500 watts when on high heat. That's 12.5 amps. Curling irons, flat irons, and other heated styling tools have similar draws. You want to plug these devices directly into a bathroom outlet, and that outlet should be GFCI protected. And if you don't know what a GFCI outlet is, I'll leave a link to a video I did on them not too long ago. All right, what about laundry and cleaning appliances? Washing machines and dryers. Well, washing machines typically draw around 10 to 15 amps with power surges when the motor starts. Electric dryers draw even more. They usually require 220 volt circuits pulling 20 to 30 amps. So these are not just don't use an extension cord items. They're you physically can't use an extension cord even if you tried items. Gas dryers still need 110 volt power for the motor and controls, and they shouldn't be on extension cords either. Vacuum cleaners? Yeah, I know that's surprised you probably, right? But modern vacuum cleaners, especially those with strong suction or motorized brush heads, can draw 8 to 12 amps. Now, you might use an extension cord with a vacuum for a few minutes of cleaning, but using one on a regular basis will for sure increase your fire risk. And that voltage drop thing, that will damage the vacuum's motor. So if you need an extension cord for a vacuum, use a heavy-duty cord rated for at least 14 gauge wire. Keep it as short as possible and never use it with other appliances running on the same circuit. What about power tools and outdoor equipment? Well, this category needs special attention because power tools often require extension cords. But using the wrong cord can be just as dangerous as using no cord at all. So here are some tools that you should never use standard extension cords with. Table saws and miter saws. Now these stationary saws can draw 12 to 15 amps continuously and create massive power surges when starting. A standard household extension cord will cause voltage drop, and that's going to make the blade slow down under load. This is dangerous because it increases kickback risk and can damage the motor. Table saws should be on dedicated circuits, and if you have to use an extension cord, it needs to be 12 gauge maximum and no longer than 25 feet. Air compressors. Now these are power hogs. They draw about 15 to 20 amps on startup. The compressor motor creates huge inrush currents that can trip breakers or overheat undersized cords. Many air compressors require 20 amp circuits. Never use anything lighter than a 12 gauge cord and keep it under 50 feet. Welders. Arc welders can draw 20 to 40 amps or more and often require 220 volt circuits. These should never be on extension cords at all. If you're in a situation where you absolutely must extend the reach, you need special industrial grade welding cables, not hardware store extension cords. Portable heaters and heat guns. Heat guns draw 12 to 15 amps and concentrate heat in one spot. If that spot is near your extension cord, you're creating a fire hazard. These should be plugged directly into outlets whenever possible. Now here are some more high wattage power tools that need heavy duty cords. Circular saws, they draw about 10 to 15 amps. Reciprocating saws, they draw 8 to 12 amps. Belt sanders, 8 to 13 amps. Planers, 8 to 15 amps. Routers, 8 to 15 amps, especially the variable speed models. Angle grinders, 7 to 15 amps, and that depends on the size. Pressure washers, 10 to 15 amps. And electric chainsaws, 12 to 15 amps. So what's the correct way to use extension cords with power tools? If you have to use an extension cord with power tools, here are some non-negotiable rules. Wire gauge, this matters more than you think. For 50 feet or less, 14 gauge minimum for tools up to 13 amps. 12 gauge for tools up to 15 amps. For 50 to 100 feet, 12 gauge mandatory for most tools and 10 gauge for high draw tools. For 100 plus feet, now you're pushing it. Use 10 gauge minimum and consider that voltage drop may still damage your tools. Now remember, the smaller the gauge number, the thicker the wire. A 10 gauge cord is much heavier duty than a 16 gauge cord. Every extra foot of cord adds resistance. That 150 foot 16 gauge cord you bought at the hardware store, well, it's causing a voltage drop that makes your 120 volt tool receive only 100 to 105 volts. Your tool is going to run hotter, it's going to work harder, and it's going to die sooner. You want to make sure that it's outdoor rated. Even if you're using tools in the garage, get outdoor rated cords. They have thicker insulation, better weather resistance, and they're built for abuse. Look for cords marked with W in the designation, like SJTW or SJOOW. You also want to check the amp rating on the cord. Every extension cord should have a tag showing its amp rating. If your tool draws 12 amps, your cord needs to be rated for at least 13 to 15 amps to give you a safety margin. Lawnmowers and pressure washers. Electric lawnmowers draw 6 to 12 amps, and you absolutely need an outdoor rated cord. But believe it or not, many people use cords that are too long or too thin. For a 100-foot run, you need at least a 12 gauge cord to prevent voltage drop that could damage the motor. Electric pressure washers are similar. They draw 10 to 15 amps and often run for extended periods. Use a heavy-duty outdoor cord. Keep it dry and never let it sit in puddles. Now, what are some tools that you can use standard cords with? Lower wattage tools that are generally safe with quality 14 to 16 gauge extension cords. Well, drills, jigsaws, orbital sanders, rotary tools like Dremels, LED work lights, battery chargers for cordless tools. Even with these, you want to use the shortest cord possible and inspect it before use. And as far as appliances, what can you use with extension cords? Well, lamps and lighting fixtures, phone chargers and tablets, televisions and entertainment systems, but it's much better to use surge protectors with those. Fans. Doesn't matter if they're box fans or oscillating fans, but not the large floor fans that you would see in a workshop or something like that. Computers, monitors, and small electronics. But once again, even with these items, extension cords should be temporary solutions, not permanent fixes. So what are the safe alternatives and solutions? Well, the best one is just to install additional outlets. If you find yourself needing more outlets in a room all the time, then hire a licensed electrician to add them. This is the safest, most permanent solution. Electrical codes require outlets every 12 feet along walls for this very reason. Next best solution is to use surge protectors. Surge protectors with circuit breakers are better than extension cords for multiple low power devices, but they're not a substitute for proper outlets for high draw appliances. Next best one is to use heavy duty extension cords. And once again, this should only be a temporary fix. Choose the right gauge, 16 gauge for up to 13 amps, 14 gauge for up to 15 amps, 12 gauge for up to 20 amps. Keep it short. The longer the cord, the more resistance and heat. Look for the UL listing. Never daisy chain multiple extension cords. That's when you connect multiple extension cords together. Never run cords under rugs, carpets, or furniture. Never use indoor cords outside. And then lastly, just rearrange your space. Sometimes the simplest solution is rearranging furniture so appliances can reach existing outlets directly. Now, what should you be on the lookout for? Well, you want to check your extension cords on a regular basis for any danger signs. If it's warm to the touch during use, a cord should stay cool. Discoloration, especially brown or black marks. Melted or cracked insulation. Exposed wires. Loose connections at either end. A burning smell. If you see any of these signs, stop using the cord immediately and replace it. Also, check your outlets. If a plug feels loose, the outlet is warm, or you see discoloration around the outlet, call an electrician. These are signs of a failing outlet that could cause fires. Remember, extension cords are temporary solutions for low power devices. Nothing more than that. When you treat them as permanent power sources for heat generating appliances and high draw equipment, you're gambling with your safety. Hiring an electrician to install a proper outlet is typically $100 to $300. The cost of replacing appliances damaged by voltage drop could be thousands. The cost of a house fire could be everything. So when in doubt, plug it directly into the wall outlet. If it can't reach, call an electrician. Your family's safety and your safety is worth the investment.